Hello friends. Just 6 days ago, on July 9, 2026, OpenAI released GPT 5.6, a brand new family of AI models called Sol, Terra, and Luna. But buried inside the launch announcement was a number that stopped a lot of people in the AI world cold. Before shipping those models, OpenAI spent over 700,000 GPU hours on a single safety activity called red teaming. That is roughly the compute you would need to train a serious large language model from scratch, and they burned it entirely on trying to break their own product before anyone else could. So here is the question we are answering in this video. What exactly is AI red teaming? Why does it matter so much that a major AI lab would spend that much compute on it? And what does a red team actually do all day? Let us find out. Alright, let us define the term. Red teaming means a dedicated team of experts deliberately tries to break a system before real attackers get the chance. Think of it as hiring a lockpicker to find every weak point in your building before a burglar does. The name actually comes from military war games. In the early 19th century, Prussian army officers used colored tokens on tabletop maps, blue for their own forces, and red for the simulated enemy. During the Cold War, the United States adopted the same idea, using red teams to simulate Soviet attacks and pressure test defensive plans. The concept eventually crossed into cybersecurity, and then into AI. The 2023 White House Executive Order on Safe, Secure, and Trustworthy Artificial Intelligence gave it a formal definition: a structured testing effort to find flaws and vulnerabilities in an AI system. That definition is now the industry standard. Next, let us look at the specific attacks a red team actually runs. Now look at this. Red teams probe AI systems using 4 main attack categories. First, prompt injection, where an attacker sneaks hidden instructions into data the model reads. For example, a malicious document that silently tells the AI to ignore its safety rules and leak sensitive information. Second, jailbreaking, where someone crafts a request that convinces the model to drop its guidelines entirely, such as asking it to roleplay as an AI with no restrictions at all. Third, tool misuse. Modern AI agents can browse the web, run code, and manage files. An attacker exploits that by tricking the model into taking actions it was never authorized to take, like deleting files or sending data externally. Fourth, memory poisoning. If an AI stores past conversations, an attacker can plant false context that quietly warps every future response. Up next, we will see how teams automate attacks like these at a truly massive scale. Here is where it gets interesting. Red teams today use 2 very different methods, and the best programs combine both. Automated red teaming means you point one AI model at another and let it fire off attack attempts at machine speed. For the GPT 5.6 launch in July 2026, OpenAI ran over 700,000 A100-equivalent GPU hours of this kind of automated testing, hunting specifically for universal jailbreaks, attacks that work across many different contexts at once. That process found a jailbreak powerful enough to unlock 83% of the model's cybersecurity benchmark tasks before targeted mitigation shut it down to 0. Automation wins on scale, but it has a blind spot. It tends to rediscover known failure patterns. That is where human red teamers step in. Skilled humans think creatively, invent brand new attack chains, and understand the real-world intent behind a harmful request in ways an automated system simply cannot replicate. Up next, a large-scale public competition showed just how necessary both layers really are. If you still think picking a more capable model protects you, this result should change your mind. On March 23, 2026, NIST's Center for AI Standards and Innovation published findings from a large-scale public red team competition run with GreySwan and the UK AI Security Institute. More than 400 participants submitted over 250,000 attack attempts against 13 leading frontier models in realistic agentic scenarios, agents that could browse the web, run code, and manage files. The headline result was stark. At least one successful attack was found against every single one of those 13 models. Not one escaped. And here is the part that really matters. The researchers found that model security did not track model capability. The smartest, most capable model was not the safest. You cannot simply buy a better base model and call the problem solved. Every deployed AI system needs its own adversarial testing program. That brings us to why this has now become a global legal and business requirement. So where does all of this leave us? Red teaming has crossed a clear threshold. It is no longer a best practice that forward-thinking labs happen to follow. Starting August 2, 2026, the EU AI Act enters a major new enforcement phase. Organizations deploying AI in the European Union face penalties of up to 35 million euros, or 7% of global annual turnover, for failing to meet adversarial testing requirements. The market reflects that urgency. Industry data puts AI red teaming at $1.3 billion in 2025, projected to reach $18.6 billion by 2035, a compound annual growth rate of 30.5%. The mental model to take from this video is simple. Use automated testing for scale, so you can probe millions of attack paths fast, the way OpenAI did with GPT 5.6. Layer in human experts to catch the creative, unpredictable attacks automation misses. And run both continuously, not just before launch. Every AI system that touches real users is a target. Red teaming is how you find the holes before someone else does. Thanks for watching, and we will see you in the next one.